I'll just say I did it right.
But I mean, she usually gives us extra time if we bend and tweak anyway.
All right, guys. So today we're going to do a tiny bit review, okay, of inequalities. And then I am going to introduce you to a little bit of calculus with inequalities. But it's a pretty nice, easy, short lesson. Yes! All right, so did you guys read the first page? You guys remember what a greater than symbol looks like, what a less than symbol looks like, greater than or equal to, less than equal to, right? So whether it's included, not included. So this just kind of went through all the notation. That's all this is, right? And then just reminding you guys that you guys do remember that if you are solving an inequality, that if you're in a step of your algebra, if you multiply or divide both sides by a negative, what happens to the inequality? Flip signs. Perfect. Okay. All right, so we're going to start way back to grade 9 is when you guys got first introduced to linear inequalities, right? That's solving for one variable, right? So this is just kind of a, like I said, an intro to what we need the pre-calc to be able to do the calc. All right, so this little guy, you probably won't need my help. Could I avoid flipping the sign? Yes, I'm not going to because I want to flip the sign. Would you guys agree that if I took the x over to the 6, I could avoid flipping my sign? It's just I hate my x on the right-hand side. But again, if you want to do that, go ahead. But I want the example to show me flipping the sign. So I'm going to bring the 6 over to the x and the 1 over to the 4. All right, so I'm going to get rid of the 1. And then I'm going to get rid of the 6. So then I'm going to get a minus. 5x is less than, minus 4 minus 1 is minus 5. Right. So then divide both sides by minus 5. Right, so therefore x is no longer less than, it is greater than 1. Right, and then just to quickly, guys, if you wanted to, this would be the other way. You would have done it. Would you guys agree that if I took everything to the other side, it would have looked like that? All right, and then you would have still divided both sides by 5. So then you would have got 1 is less than x. Are those two statements the same? Yes, they mean the same thing. And if you're not sure, look at the opening of the inequality. Is the opening on the inequality to the same variable, right? See the openings on x in both statements? They mean the same thing. X is greater than 1 means 1 is less than x. All right, so grade 9, introduced to linear. Okay, do you guys remember when you're introduced to quadratic inequalities? 20-1, right? You had a whole chapter of solving quadratic inequalities. Not a whole chapter, but one lesson. Okay, so something like this, I'm not going to do the algebraic way. I'm going to do the easier way that you learned, which is basically the number line piece, really focusing on what greater than 0 means. Okay, because you guys all agree that if I asked you to solve this, x squared plus 3x minus 10 equals 0. You guys all agree you could do that? So we still need to do that. Yes. Right, so go ahead and factor that and solve it. All right, so did you guys get negative 5 and 2? Right? So what's the difference between me asking you to solve the equation where it equals 0 versus solving the inequality when it's greater than 0? Pardon? Yes, but in general. Like if you talk about this -5 and this 2, what does those two values mean? Those are the only two numbers in the world that will make this equation equal to 0. Right? Does that know what that means if it's an equal to? So if it's greater than 0, do you guys agree that there could be many possible answers? So your solution with a quadratic inequality will revolve around these values. So you still need to solve it for 0 because those are your key points. So in this situation, that's your critical numbers. So what you can do is check the areas around those two intercepts. So what I mean by that, there's basically 3 areas that it could be greater than 0. So one area is this side of the 5. Another area that it could be greater than 0 is between -5 and 2. And the last area that it could be above 0 is above 2. So those are 3 possible solutions. And guys, I'm hoping you go back. It's a little deep. It's way deep in there. Picture the graph. If you're picture this as a function, because I know it's not a function, but if you picture it as a function, right? Do you guys agree that you have a quadratic inequality that would open up if you graph this as a function? Graph that as a function. It's a quadratic graph, yes? That opens up, right? Basically, the -5 and the 2 are the x-intercepts, so it's where that graph crosses the x-axis, yes? So if I ask you where it's greater than 0, that just means where is the graph? Above the x-axis. That's what it means, right? If you made this x squared plus 3x minus 10 into a function. So that's what this number line does. It basically explores where it can be above or below, and you need those x-intercepts regardless, okay? So then how you would check is in 20-1 you would do test points. So pick a test point on the left-hand side of -5. It doesn't matter what number. Sure. So we're going to test, right, x equals -6. So I don't actually care about the numbers. You can just do this quickly. So if you picture these factors, if I put a -6 into the x plus 5, what do you guys get? -1, do you guys agree? So it's a negative number because I don't actually care what it is. Right? And if I put -6 into the x minus 2, do you guys agree that that's going to also get me a negative number? So a negative times a negative is a positive. So guess what? On the left-hand side of -5, it's going to be positive, which means it's above 0. And could you put the actual numbers in there if you wanted to, guys? Yeah, it's just saving time. I don't actually care what the number equals. I just want to know if it's positive or negative. So pick a test between -5 and 2. Exactly. Anytime you can pick 0, I like 0. All right, so if you put 0 into the x plus 5, that's going to give me a positive number. If I put 0 into x minus 2, that's going to give me a negative number. So I know that in between -5 and 2, it's going to be negative. So that means less than 0. So that is not a test solution. That's not a test or a solution area. And then my last little guy, pick a test value. So x equals what? 4, sure. And again, it does say greater than, so I can't, don't ever pick the x-intercepts, right? Even if it says equal to, because if you do, it gives you that on the x-axis. Always pick above or below, depending on what the inequality symbol is. So if I pick 4, if I put 4 into the x plus 5, that's going to give me 9, which is a positive number. And then if I put 4 into the x minus 2, that's also going to give me a positive number. So therefore, positive times a positive is a positive. So my two solution areas, right? So this inequality has a solution. So my solution is where x is less than where? -5, or when x is greater than 2. That's your solution. And again, the only way, okay, that you can get these test areas wrong is if you factor it wrong. Because do you guys remember a little bit now from 20-1? Your solution with the quadratic is either going to be both on the outside, right, or in the middle. Can it ever be the middle and the outside for a quadratic? It can't be, right, because your branches. Right, so if it does cross the x-axis at 2 points, it's either going to be the out two or the middle. It has to be. Okay.
It's the other way of doing this. I remember I hated this when I did the other way. I can look it up myself, but
Didn't you do the cases?
Yeah. Yeah, your cases. You actually like the other way better.
I did like the
Yeah.
other way better. What was
Yeah.
it? You made it negative or something?
Well, you had to do a number line. You had to do both of these because to make it that just because maybe someone in the other class liked the other way too. So greater than 0 means both of these are positive, and then you graph both of them, and if they overlapped, or you made
No, I
both of
refused
these
to
are
graph them. I just read them
negative.
down and guessed.
Yeah.
Yes.
And this number line scenario is going to help us with the calculus, so I'm not going to show you the other methods because we use number lines and to find positive and negative integrals. So this is going to work the best for where I'm taking you guys. Okay, so you guys go ahead, do the your turn. But before you start, what's the only thing you guys can do to start factoring this? Good, 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 good. Some people look at that and they always forget GCF, so go ahead and do that. Thank you. Do we all get the middle area? So I think in your calc textbook, which is what your assignment booklet is built from, they a lot of times will use this notation. Right? So don't freak out if they use your interval notation. Is it faster and easier to write? Yeah. So again, I don't care which notation you use. Same thing, so just let's go back up in this one. So if you use the other notation for this one, it would be negative infinity to negative 5, both round brackets, or 2 to infinity. Right? And again, either one, but I do think your answer keys, a lot of times we'll use your interval notation. All right. So now, with example 3, this is a cubic. Do you guys all agree? Did you ever solve cubic inequalities? No, you have not. Have you solved cubic equations? Yeah. But do you guys see already that if you just solved a quadratic inequality, you can solve a cubic, a quartic, a quintic, doesn't matter? Because it's the same idea, except instead of testing up here, we test 3 areas because we only have 2 x-intercepts. With a cubic, how many x-intercepts are we going to have? 3. So you're just testing more areas. That's it. Right, so for this one, I'm not going to, because the focus is not our pre-calc. So is this nice that it's already factored for us? So if I ask you, hopefully in the textbook, the assignment booklet is factored for you. Otherwise, do you guys know how to factor a cubic? Remember, yes you do. All right, you have to do synthetic division. You have to find a number that sets it equal to 0 when you put it in, and then synthetically divide it out, break it down to a quadratic. Again, not our focus. So this one is factored already. So then you would get your critical numbers. So the first one's going to be x equals 0. The next one is going to be x equals 1. And then next one is going to be x equals -2. All right, so those now, put them on the number line and do your tests. -2, 0, 1. Doesn't have to be drawn to scale. Let's go ahead and do those tests. We good with those test areas? Yes. So the nice thing is, guys, with this chapter, I really encourage you to bring your graphing calculator, because can you now use your graphing calculator to check a lot of this? Yeah. Can you use it on a quiz or a test? No, right? But you definitely bring it to class. It's a nice kind of, yeah, I did it right. I did my x-intercepts right. It's just a nice quick visual that I would really encourage you guys to use your calculator, especially when we start curve sketching, right? Because we're going to be graphing things without our graphing calculator, right? So you're going to be collecting information using calculus to sketch these graphs that you've never seen before, right? So it's nice to sketch it and then use your graphing calculator to confirm what you think it looks like, okay? And some of them you have seen before, but some you have to just trust the calculus that you built all your information correctly. Not today, though. We're just itty-bitty little steps. All right. So here, a rational, okay, inequality, right? You have not done these before, okay? But what you have to do to be able to get your critical numbers, okay, is you still have to solve it like normal, because do you guys agree that if I set this equal to 0, you guys could solve that? Yes, so you'd set it equal to 0, and basically you're solving the top. Would you guys agree with that? That when you set this equal to 0, the bottom multiplies across, it goes away. So then you're solving the top. That's where, in this situation, 2 of your critical numbers are going to come from. But the other piece that you have to do is also solve the bottom. Because what happens with the bottom, guys? When you're dealing with rational functions, picturing the graphs, what does the bottom create? Asymptotes. Okay, do you guys agree that the bottom creates vertical asymptotes? those are also critical numbers. Because do you guys agree that it could change direction, right, at that vertical asymptote? Or something could, if you guys are picturing some of the graphs you guys have done in the past, a vertical asymptote, the graph approaches, right? So at that point, it could go from positive to negative, right? So that means with your rational functions, you have to solve the top and you have to solve the bottom, okay? Because the bottom, that vertical asymptote potential, is another point where it could change from positive to negative. Right, and that talks about all here. So these 3 little bullets talk about what I just said, right, to remind you. All right, so to get our critical numbers, we solve it as well. So we solve the top and we solve the bottom. Right, because again, that vertical asymptote is a critical point that it could go from positive to negative. So solving the first one, factor out a x. So 2 of my critical numbers are x equals 0 and x equals negative 2. My second critical number, or my third I should say, not second. So then I have x minus 1 equals 0, because if I square root both sides, plus or minus 0 is still just 0. And then add 1, so x equals 1. And you guys also know that point as, if I were to graph this in the future, which you will be, what would I put at x equals 1? A vertical asymptote. Okay? But again, not graphing. It can be a value that it could change from positive to negative, because if you guys are picturing, right, the graphs, right, it can change direction there. Right? Okay. So just kind of putting little plants in your head, seeds in your head to think about, because you will go further with those values in the near future. So we have negative 2, we have 0, and we have 1. So if I'm picturing my function, just so you guys can see, this is what I'm looking at when I put my test values in. Right, so I'm picturing this when I do my test values. So test equals, let's use, exactly. I'm still gonna, but yes, the bottom will always be positive.
So we can just test the function.
Yeah, absolutely. So whatever x equals -1. Don't know why I put an extra thing over there, because one. And remember, can you pick whatever numbers you wanted? I just like picking nice numbers close to my critical values. So this is all I'm saying, guys, when you're testing now, right? So if I do -3, I don't actually care. If you want to, technically, guys, if you blah, 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 could you just put -3 into here on your calculator to see if it's positive or negative? Right? I just find that's time consuming, right? Because I wouldn't write all this down. Right, so if I put a -3 in, I'm going to get a negative. -3 in here, I'm going to get a negative. Now if I put a -3 in here, it's being squared, so as Kaya said, it'll always be positive. So a negative times a negative is a negative. Negative times a negative is a positive, divided by a positive. This area is always going to be a positive. Okay. So if I do my next test point, negative 1 if I put in there, -1 is going to be, -1 plus 2 is a positive, divided by a positive. So this area is always going to be a negative. So that means it's just below the x-axis. This graph would be below the x-axis from -2 to 2. It's above the x-axis on the left-hand side of -2. So then if I put half in, right, that's going to be a positive, positive, positive. So here I'm going to deal with positive and then put my 2 in. That will also be positive. Hello? Yes. Mm-hmm. will send it up. You bet. Thank you so much. Captain, you can go grab your binder and stuff at the office. Yeah. All right, and then our last one, do you guys agree that that's all going to be positive? Positive, positive, positive. Right, so with this one, we have 3 positive areas. So then my solution would be x is less than -2. And between, so or between 0 and 1. And greater than 1. Sometimes students ask me, can I just put 0 to infinity? And my answer is, because here it says greater than, right? So can I include the x-axis? No. If it said greater than or equal to, then could have I? Yes. But since it said greater than, 1 is not greater than, it is equal to, right? So I do have to do each chunk separately, right, because of the greater than symbol. Okay. And then I guess this would be negative infinity to -2, or 0 to 1, or 1 to infinity, using the other notation. Yep, lots of ors. Right, so that, guys, we have one more question to do, just a little hint of calculus today. That is your review of the pre-calc. Okay, so this is all the pre-calc this idea of intervals, positive versus negative, bless you, is going to help us curve sketch where the graph's going to increase or decrease. Okay. So that leads us into increasing or decreasing. So if you guys are picturing a graph, can you guys visualize how calculus is going to help us figure out where the graph is increasing or decreasing? Because what is our first derivative, guys? Right, do you guys agree that our first derivative is slope? So guess what? If we find our first derivative, we can find where the graph is increasing or decreasing, which in a layman's term just means we can find the graph if it's going to go up or down. Okay, so that's what we're going to do, is we're going to do, this talks about that, right? Obviously if the first derivative, right, we put a value in and the value ends up being positive, guess what? At that value, it's going to be increasing. If we find the first derivative and we can put a value in and it ends up being a negative number, that means the graph must be decreasing, right, at that point. So this kind of talks about all that, but the same thing is, picture your derivative graph, guys. Whoopsie. So if we do this, don't write this down. If this was, say, quit it. Goodness. Right. Yes, sorry. Right. So if I gave you guys this, okay, and I asked you guys to sketch the derivative graph, we should be able to do that, yes? So our turning points are key spots. Do you guys agree? So those turning points are where it ends up being, right? Do you guys agree that on this side of the turning point it's increasing, and on this side of the turning point it's increasing, right? And then between the two turning points it is decreasing. So when we did our sketch, we did this, right? So that would be where the critical values were. Do you guys agree? And then I know that on the blue part it was increasing, so then I knew it was above. And then between the two turning points it was decreasing, so it would be below. And then on this side it's increasing again. That's a really bad sketch, but Do you guys understand? That's how we sketch things. So what we can do is these two values right here are our critical numbers. Do you guys agree? And guess what? Those two critical numbers come from finding the derivative and getting the x-intercepts. Do you guys agree that that's what those two numbers would be? So those would be my critical values that I would have to test. So if that doesn't make sense, watch. So right here, find the intervals of increase and decrease for the function 1/3 x cubed plus x squared minus 3x. So this is a cubic graph, okay? So potentially it has how many turning points? Not x-intercepts, how many turning points? 2. Do you guys agree that there's 2 turning points? Could potentially have 3 x-intercepts, but that's not what I'm asking. So it has potentially 2 turning points. So I can find those turning points by finding the first derivative, because do you guys agree first derivative is going to be a quadratic? Yeah. So let's find my first derivative. So my first derivative, so this is your first piece of calculus that's going to help us with chapter 4 and 5. So first derivative, so I'm going to bring down the 3, so 1/3 times 3 is 1, x squared plus 2x minus 3. Right, so are you guys picturing that is my derivative graph? You guys agree? So that's my derivative graph. So I need those critical values. So my critical values is I take my derivative graph, set it equal to 0 to get those critical numbers. And what are the two numbers I'm going to multiply to give me 3? Right, 3 and 1. And the 3 has to be positive, and the 1 has to be negative. So x equals -3, and x equals 1. So basically what I just did, guys, is I found these two critical numbers, right? Obviously this isn't the graph, but that's what I just did, is I found those two critical numbers. So then we can use our idea of inequalities, because I want to know, find the intervals of increase and decrease. So I want to know where it's above, and I want to know where it's below. So now we can use our pre-calc of number lines, right? Because those are the two numbers, the graphs, that's where the graph's going to change from positive to negative. So then I have -3 to 1. So then do your tests. So I'm going to test x equals -4, x equals 0, and x equals 2. So now this is sometimes where students flub it up. Am I testing it on the original, or am I testing it in my slope function? Right, it should make sense. I'm testing it in my slope function. I'm not going back to my original. The only time I'd go back to my original is if I wanted ordered pairs on the graph. Okay? So here I'm testing it because my slope function tells me where it's positive or negative. So if I put -4 in, same thing as before. If I put -4 into the x plus 3, I get a negative. If I put a -4 into my x minus 1, I get a negative. Right? So that must mean on the left-hand side of -3 on the graph, it's going to be increasing. That's what it just said. Or that's what this is saying. So now if I test 0, if I put 0 into the x plus 3, I get a positive number. And if you hate just saying positive and you want to put a 3 there, can you do that? Right? Because I don't care what the number is. I just need to know if it's positive or negative. But if you want to put the number in, fill your boots, it's good. Right? And then if I put a 0 in, 0 minus 1 is a negative number. Right? So then between -3 and 0, it's decreasing. And then my last little piece here is 2. So therefore 2 plus 3 is a positive, and then 2 minus 1 is a positive. So what this says is, right, the graph is increasing. So it's increasing from negative infinity to negative 3, or where x is less than negative 3, or x is greater than 1, and it's decreasing so it's decreasing between negative 3 and 1. So what I did right before class, because this is weird to picture, I graphed it, right, and I took a screenshot. So you guys have that capability of doing this, yes, on your calculator. So I just graphed the original function, right? That's the original, right? And then you guys can see, because we just said that it's increasing from where again? I'm just going to move that over so it's close. Da-da. Come on, move it over. Get rid of this. Oh.
This sound effects really help.
I know it does, doesn't it?
It's true.
All right.
Oh my god.
All right. So now, if you guys can see this, I'm saying it's increasing, right, from negative 3, right, less than negative 3. So increasing, 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 increasing. Do you guys agree that that turning point is at negative 3? Right? Oops, sorry. Right, so it's increasing here, right, and then that turning point, so this turning point right here is, guess what, at negative 3. And then I'm also saying it's increasing from 1 and further. So you guys can see that as well. Guess what this point is? This one is at 1. So it is increasing from negative infinity to negative 3. It's also increasing from 1 to infinity. But it's decreasing from negative 3 to 1. Right? So that's what this calc just told us. Okay? So again, we'll talk about finding max and mins very soon, but today is your first little intro to help to show us how slope can help us curve sketch on a graph. Just one little piece. We need way more information, but that's coming soon. All right. So please, please, please definitely bring a calculator. Your graphing calculator will help a lot just to confirm things that you are figuring out through calculus. But this is some pre-calc and a little bit of calc to kind of warm you up into going into chapter 4 and 5. So 4 is basically going to give us all the calculus that we're going to need to start curve sketching in chapter 5.